Hello friends and welcome to this video. Today we are going to focus on CMake targets and really explore different kinds of targets you can set up with your CMake projects. Along the way, we will also have a chance to see that we have different ways we can specify the C++ standard that our CMake project is going to support. We can set this globally and set this as a default standard in our CMake project, or we can even set this up on a target basis, as we have been doing so far without really knowing too much about what we were doing. But today we are going to shed some more light on these things. We will start by setting up a simple project which is really going to have a bunch of files in. We have a dog class which is really nothing complicated. We have a bunch of member variables. We really have one, so it's not a bunch, but this is okay. And we have a constructor here. We can do some things using these methods here. Nothing complicated here. We also have a logger header which can be used to log things. You see we have a method or a function to log stuff. We are going to pass it a const card parameter, and we can specify which kind of logging we want to do. We can put out a message, a warning, or say that we have a fatal error here. If you go down, you're going to find implementations for these files, so nothing complicated here. We have an operations header which is going to contain a single function to add stuff up and give us a result. We are going to pull all these things together in the main CPP file. You see we are including them here, and we are just using these things. We are using our method from the operations header, we are using our dog class, and we are logging data using all the facilities from all these three files. Let's go to our file system and show you how this looks. This is really nothing complicated. Again, we have a main CPP file which is living at the root level in our project, along with our CMake list.txt file. You can set things up like this if you want. We have an include folder which is going to contain our header files, and we have a source folder which is going to contain our implementation files. Let's look at those implementation files. Nothing complicated really. We have the definitions for our constructor and the destructor for our dog class. In log CPP, we have the implementation for our function to log data. And in operations, we have the implementation of our add function here. So the first thing we are going to do is to build this project as a single target. After that, we are going to see that we can split things into different libraries that are going to be really different targets. And we are going to see that it is possible to also build individual targets. So for example, we can specify that we want to build a library. We can specify that we want to build an executable. We can do all kinds of crazy things, and we are going to see this in this video here. And we will also have a chance to see that we can set our C++ standard at different levels in our CMake list.txt file. So let's get started. The first thing is to build this entire application as a single target. The target is going to be an executable, and we can achieve that using the add executable command as we have seen here. So we are going to specify the name for the target, and we are going to list our source files that are going to make up our target. This is how we can achieve this. After we have our target set up, we are going to attach a bunch of properties to it. For example, we can tell it where to find the include files, and we do that using the target include directories command. We can also specify that we want C++20 for this target, and we can do that at the level of our target here. And this is going to work just fine. This is what we have seen so far, but we have a bunch of files that we are bringing together in our CMake list.txt file. So let's try and build this project. We will bring up a terminal window, and this is going to bring us in the current source folder. We want to make sure that we have a build folder up. So let's clear and do ls. We have our files in here, and we have a VS Code folder here that we're not going to mess with. It is just setting up the project so that it can look better in Visual Studio Code, but this has nothing to do with CMake so far. We're going to go up and clear, and we are going to do ls. We are going to see that we have a build folder. We can remove this. and we are going to start from scratch. So let's create a directory called world, mkdir world. We are going to cd into our world directory, and we are going to call CMake to generate a project for us. We are going to use Ninja because it is flexible, but you can really use any kind of generator. Any of the generators we have had a chance to look at is going to work just fine. So I am going to say CMake, and I am going to specify my generator to be Ninja. And I want to use the default compiler. If I want, I could specify GCC or Clang, but I am just fine with the default compiler, which is going to be the compiler from Microsoft, because I am doing this from Windows. So I am going to tell it the location for my source files. And if I hit enter, this is going to generate my project. And let's wait for it to do its thing. And our project was generated in this folder here, and we can build it. So let's build it. We're going to say CMake build and specify that we want to build the project in this folder. And our binary is going to be generated. You see that we have it here. And if we do hello app binary, we are going to run our program. So let's see what we have from the main CPP file to really understand what is going on here. So we are including operations, dog and log, and we are computing the addition of 10 and 70. This is going to give us 80. We're going to print that out. That's what we see right here. After that, we are going to create a dog object called Flitzy, and we are going to print information about our dog. So we are going to print the information here. You see that we have the constructor for our dog object called this is just fine. And we are going to log data, and we are going to say that this is a fatal error. We are going to say hello there, and we see this printed out down here. So our program is really working. We can try to change things up a little bit. For example, we can say that we want to add up 2 and 70. Let's do this. And if we go down again and run CMake build and specify the current directory, the project is going to be built again, and we will have a new binary generated. If we run it, we're going to see that this is going to account for the changes we just did here. And the main message is that we are wrapping all this project into a single target. And a target in CMake is really something you want to get out of your project. We are doing all this hard work to set up these headers and these CPP files with a single goal to get an executable binary that we can run. So this is our target. But executables are not the only type of targets you can do in your C++ programs. Another common and very popular target you can do is a library, and we have different kinds of libraries we can do in our C++ projects. For example, we can set up a static library, we can set up a dynamic library, and I am not going to go into the details of what those are. If you are new to these kinds of concepts, I strongly recommend this blog post by Internal Pointers. You can go there and really learn a lot about static and dynamic libraries. This is a really good reference. I have learned a lot about it myself, and it is really good. I do recommend it. So go read it if you really think that you are rusty on the knowledge about dynamic and static libraries. What we are going to do in this video is just set up a static library, which is going to be extracting the features we have in this here and make it a reusable components that other applications can load and use in their own logic. So this is what we currently have. All these features are bundled into a single executable, but what we want to do is to, for example, extract the operations feature into a static library and let this library be loaded into our own binary executable to be used to do things. And we're going to do this using CMake. So let's go back to our project and change things up a little bit. We are going to add another target, which is going to be a static library. And we can do this using these 3 lines here. Let's make sure they are aligned properly. We are going to add a library target. The name for it is going to be operations. It is going to be a static library. Again, if you don't know what a static library is, please come back to this blog post and really read all you can about this. And we are going to specify the source folders that are going to be making up this library. And it is going to be our operations.cpp file. After that, we are going to give it an include directory. So we are basically going to tell CMake where to find the headers that make up this library. This is what we are doing at line 19 here. And we use the target include directories command exactly like we did on our executable target. And we will tell it to compile in C++ 20 mode. So we are setting up a library target. And now we don't want the operations CPP file to be part of our hello app binary target. So we're going to remove this here. We can do something like this. And we will load this library to be used in our executable. Now, to do that, we will need to set up another command, which is going to load the library into our hello app binary target. The command is going to be target link libraries. Let's do this. We're going to say target link libraries. You can look this up in the CMake documentation. You're going to learn all you can about it. But what we are saying, we want the hello app binary to depend on the operations static library that we just set up on top here. So this is how we're going to say it. We are going to say hello app binary is going to publicly depend. So this is going to be public on the operations library. And once we do this, we are going to be building our project in 2 steps because we have 2 targets. The first target is the library that our executable depends on, and this is going to be built first because this is logical. We want to build the dependency first and then build what depends on that dependency, if that is making any sense. So if we go back to our terminal, let's bring this up through the view menu here and show our terminal window. And we are going to clear everything we have, and we are going to run CMake again to build our project. We are going to see that we are almost doing the same thing. But if we list the files in here now, we are going to see that we have an operations library on Windows. This is our generated library that is going to be loaded into our C++ program, and this is going to work just well. So we just split our program into 2 different targets. One is our operations static library, the other is our executable, and we are linking those up using the target link libraries command. So we are really working with multiple targets in our program, and this can really allow you to split things up to make them easy to manage in your C++ project. Now, this is not the only way to do things. Some people like to set up completely separate libraries and put them in separate folders. For example, we might want to take our logging feature and make it self-contained. In that, we can set up a single folder called logger, for example. And we might move all the logging features inside this folder. Some people like to do things this way. So we might go inside the logger here and set up an include folder. And we might also set up a source folder inside. We can do something like this and move all the files from our general project in that folder there. So let's take our log header file and move that in there. So we're going to go in logger, include, and put in our header. And we are going to go in our source file and remove log.cpp and move that into our logger folder in the source folder. We can do something like this. You see that our project has changed a little bit. We need to take this into account. So we want to build our logging features as a separate library, and we are going to add another library target for that. So what we can do is go down and make sure we put that right here. We are going to say add library. This is going to add another target. The name is going to be logger. It is going to be a static library, and we are going to specify the files that make it up. And the files that make it up from the perspective of our CMake list.txt file is living in this folder here. We are going to go in logger, go in src, and find the file here. This is going to be making up our library. We are going to tell CMake where to find the headers for this target, and that's going to be in the logger folder and in our include folder, and this is going to work just fine. Now, the log.cpp file is no longer part of our executable target, so we are going to remove it like this. And all we have to do is go down and say that our target hello app binary also depends on our logger library. So we can add something else and say logger here. And this is all we need to do. Our project is now split into 3 parts. We have 2 libraries. One library is operations. The other library is logger, and we are linking to these libraries here, and this is working just fine. One thing you should notice is that the location for the log.h header has changed, but we didn't inform our executable target of the location of that header. And this program is going to work without a problem. Let me show you that it is going to work. We can bring up our terminal window again, and we are going to clear and run our command to build our project again. So you are going to see that everything is going to work fine. We are going to generate a project and we are going to build it. This is just fine. If we do ls, you are going to see that we have now 2 libraries, logger.lib and operations.lib. And we can run our binary. Let's do that. And it is going to run exactly like it did before. So this is working, but some of you must be asking, how does our executable target know about the include location for our log file? Because we didn't really explicitly tell it the location for that. You see, the only thing we have for our target is the location that is directly at the same level as our CMake list.txt file. But again, if we go to our project, we are going to see that things have changed a little bit. The headers for logger don't live in this include directory. They live in the include directory that is embedded in our logger folder. And what is really happening here is that the library target logger is propagating this include directory to our target that depends on it. And this is happening because of the public thing we have here, but I don't want to go into the details of this. We will explore this later, but I just want you to know this in case you were wondering why this is working, even if we didn't specify our target include directory to our executable target. And we have really achieved what we set out to do in this video, to split our project into different libraries. And this gave us a chance to learn about different kinds of targets we can set up in our CMake projects. We can do executable targets, and we can do that using the add executable command. We can do library targets, and we can do that using the add library command, and this is going to work just fine. The last thing I want to cover in this video is that it is possible to set the C++ standard at different levels. Here we are setting this up at target level, but it is also possible to set the default C++ standard for your project in a global level and make each target pick that up and use it. One way we can do that is through CMake variables. So we can set up a bunch of CMake variables. Then we set variables using the set command as we do here. We haven't really learned about CMake variables, but we just want to see how we can use this to set the C++ standard. So we say set, we specify a bunch of parentheses. We are going to say CXX standard required, and we're going to put this on. This is going to make C++20 a hard requirement. And if CMake doesn't find a compiler that supports C++20, your project generation is going to fail because CMake is not going to find what it needs to build your project. You need to know this. After this, you can set your standard to C++20 using this syntax, and it is going to default to the C++ standard to C++20, and this is going to work just fine. So if we went down and commented out all the commands to set the C++ standard on our target, let's do that. I think these are the only ones we have in our project. And went in our main CPP, for example, and put something that is C++20 specific. Let's use a 3-way comparison operator. Let's do auto value and say value equals. We can do something like this, 10, and say 3-way comparison operator and say 20. and say greater than 0. We can say something like this, and this is going to compare 10 and 20, and we are going to get the result of this comparison in the value here. We can print this out if we want. We can say stdc out and say value, and we can say value here. This is going to do, and we can put a requirement to print this in the form of true and false, because this is going to evaluate to a Boolean. If we hover over this, you're going to see that Visual Studio Code is going to help out. We want this to print as true and false, so we're going to say stdc out and say std bool alpha. This is going to do. And if we run this project, it is going to support C++20 because we are specifying that as a global setting to our CMake list.txt file. So any target we have in this project is going to pick up C++20 and use it. This is what we can achieve with the setup that we have here. So let's view our terminal again. And we are going to try and build the project. So let's go up again and say CMake build and specify the current project. You are going to see that the build is going to be good. We have our binary. We can run it. And this is going to work just fine. You are going to see that value is false because 10 is not greater than 20. It is something we tried to do here using C++20. But if we go down in our CMake list.txt file and remove this setting, the default is not going to be C++20 and our compilation is going to fail. Let's try and build the project and see it fail. We expect it to fail because it is not using C++20, but we require C++20 for this line here to work because it is using a C++20 feature. Let's do that. We are going to run our build command. And you see that we have a bunch of errors. This is really not going to work because our project is not set up to support C++20, and our compiler is really not going to understand the meaning of what we have on line 8 in our main CPP file. So this is what I wanted you to see. We can set our requirement using a setting that is global, and this is going to be the default C++ standard in your project, or you can even set this on a target level. So for example, we can enable our things again to use the compile features command. And if we do this, we are going to see that the logger library is not going to be using C++20 because it is not setting that up explicitly. So if we build our project, you are going to see that it is going to build just fine. Let's view our terminal window again, and we are going to try and build again. Now everything is going to work because we have C++20 enabled for our hello binary executable, which is using the main CPP file. So this is going to work. But if we go in our logger file and go in the CPP file, for example, and try to do the same thing, let's grab what we just did in main, and we are going to cut this out. We don't need this in main anymore. We can put this somewhere in our logger function, and we do something like this. Now if we compile, the compilation for our target is going to fail because we are using a C++20 feature and the target is not set up to use C++20. It is going to use whatever default that CMake provides. So this is not going to be C++20 for our logger target. Let's try and build and show you that this is not going to work. Let's remove this line here. We are not interested in printing the value, so what we have in log.cpp is enough to trigger a compilation error, which we want to see. Let's make sure our terminal is visible, and we are going to build again. And if we do that, we are going to see that compilation for our target to log data is going to fail because, again, it is using a C++20 feature. And in our CMake list.txt file, we didn't tell this target to use C++20. It is using whatever default that CMake is going to set up. And at this moment, it is not C++20. So you really need to be aware of this. If we want this to work, we can either explicitly tell our target to be built using C++20 and do that like we are doing this on other targets. We can copy our target compile features command and pass that on our library target. And this is going to be applied to logger. Now this is going to work because log CPP file is going to be compiled in C++20 mode. Let's bring up our terminal window again and make sure this is building just fine. So now this is going to build and generate our binary, and this is all good. We can run our program and make sure it is doing what we expect, and this is what we want. It is working just fine. Now, the last thing I want you to see is that if you have multiple targets set up, you can specify which target you want to build. Let's go up again, and we are going to remove our build directory completely, or we can go inside. I think we can do this and remove everything recursively. From this folder, we can do something like this. It is going to be clean. We can specify that, for example, we only want to build the logger library because this is a target in our CMake list.txt file. So let's do this. We are going to say CMake. We are going to generate a project first. So we are going to use our Ninja generator, and we are going to specify the location for our CMake list.txt file. If we hit enter, this is going to choose my compiler from Microsoft, and it is going to generate a project, a Ninja project. If I do ls, I am going to see my project here. Now that I have the project generated, I can specify which target I want to be built explicitly. So for example, we can say CMake build and specify the current location and say the target we want to be built to be logger. Let's do this. Logger is a target in our CMake list.txt file. So we can specify that we only want to build this target. And this is going to only build it. It is not going to build our executable. It is not going to build the operations library. It is just going to build our logger library. And we can achieve this. If we hit enter, you are going to see that the logger library is going to be generated. If we do ls, we are going to see it generated. And you notice we don't have anything else generated. We can also specify that we want to build our operations library. We can do something like this. And it is going to build it. If we do ls, it is going to be generated. You have this flexibility in building your projects with CMake, and this is really cool. Now that these guys are in, we can also specify that we want to build our hello app binary target. We can do that. Let's do this. And if we do this, the target is going to pick up the dependencies because they are already in place and they are going to be used in setting up our hello app binary target here. Let's run, and our target is going to be generated. You see, if we do ls, we are going to see this generated, and we can run our hello app binary, and it is going to work. It is right here in our folder. So let's run it, and it is going to run and do whatever it is we want to do. This is really all I wanted to do and show you in this lecture, that you can do all kinds of crazy things in terms of targets. You can build libraries, and you can really use these features to organize your project in whatever way suits whatever you are trying to achieve in your project. Now that this is working on Windows, we can try and reuse this on Linux and see how this works. So let's make sure we push this to GitHub. I am going to bring up my window again, and let's go up to the root level for what we do here. And we are going to clear and do ls. If we do git status, we are going to see that we have episode 7 added, which is the current project we did. We are going to get added to our Git repository. We are going to commit. And I am going to commit this and push this to our Git repository. Let's do git push. This is going to be pushed up. And while it is pushing up, let's bring up our Linux box. We can do this from our Windows terminal. And you see it was pushed. And we can open our Ubuntu system and pull this up and build this on Ubuntu system. This is going to work just fine. This is going to take some time to be set up. So let's go down here. We are going to cd into our working directory. If we do ls, we are going to find CMake sandbox. I think our repository is CMake series. So let's cd into that. And we are going to do git status and see if we have no change in here. And we are going to do a git pull or fetch. This is going to pull the changes we just did on the Windows side, and we are going to merge this in. So let's do git merge in the current repository. And we are going to be adding the files from our episode 7 project. We can cd into ep007 to do this. And we are going to do ls and have our source folder. If we want, we can open this up from the Linux side. Let's actually do this. So we are going to cd into source, and we are going to have our folder here. We can open this up from the Linux side and open code or Visual Studio Code to be exact. Okay, here I have my project opened on Ubuntu Linux, and we can try to build it. You see that it is really exactly the same thing we had on the Windows side. We have our dog header, operations header, we have our CPP files, and we have our logger library wrapped in its own folder. We can bring up a PowerShell window. We can bring up a terminal window, I should say. And you see that this is working on my Linux box. We can cd up and create a build directory. So let's do this. And once we are in here, we can generate a CMake project. So let's say CMake and specify our generator to be Ninja as usual. And we are going to specify the location for our source files. We can do that. If I can type this. And what did we do here? Let's do ls and see what we just did. We need to cd into build because we created that. And we are going to generate our CMake project. So let's do that. We are going to use the Ninja generator. And we can specify the location of our source folder, which is going to contain our CMake list.txt file. This is going to use the default compiler for Ninja on Linux, and this is going to be GCC. The current version I have is 10.2.0. This is going to do just fine. And now that we have our Ninja project, we can generate any target that we support in our CMake list.txt file. You see, we have a bunch of targets. We have the operations library, we have the logger library, and we have our executable target. We can really choose any of these. Let's try and build our operations library and see how it looks on Linux. We are going to say CMake build and specify our target to be operations. And if we do this, we are going to generate a library, and you see that the extension for this on Linux is A. We can also generate our logger library. Let's do that. And it is going to be generated using the log.cpp file. Let's wait for this to be done. And you are going to see that they are going to be generated. If we do ls, we are going to find them. We can even remove them. So we are going to remove liblogger.a. And we are going to remove liblogger or lib operations. And we can remove this. And if we build our default target, which is our executable, CMake is going to see that the dependencies are not in place, and it is going to generate these libraries first and then build our hello app binary executable. And this is how things are going to work. So if we do CMake build and specify the dot and not specify a target explicitly, this is going to be building our default target, which is going to be our executable. But it is going to build the dependencies first. And this is going to work exactly as we want. If we run our program down here, let's say hello app binary, we can run it and it is going to do exactly what we want. For example, if we go in the main CPP file and change something, let's change what we are adding up and say we are adding 45 to 70. If we do CMake build again, this is going to pick up the changes and it is going to build a new binary. If we run this, we are going to see that the changes are going to be picked up and our result is going to be 115. Let's revert these changes from Visual Studio Code here because we don't really want them. So let's discard them and bring this back to how it was. And this is really all I had to share in this lecture, showing you different ways you can set up targets in your CMake projects. We can set up executable targets using the add executable command. We can set up library targets And we can specify different ways we want our C++ standard to be set up in our project. And all this knowledge is now available to you. Use it to your advantage and really organize your projects however you see fit. So this is really all I had to share in this video. I hope you found it interesting. I am going to stop here at this moment and I will see you next time.